This is assignment number 7 in the CAD course, week 7. There was no assignment 6 because you guys wrote the midterm last week or 2 weeks ago. Now, uh, it deals with creating a design table for this problem that was done earlier by you, but it was a parameterization, it was not a design table. So now we want to do that so that the design table of this model is created as you make the model. That's what I call scenario 1, and solve the problem. Uh, just remind you that if you're doing a design table problem, you have to submit not only the part, but also the Excel spreadsheet that you're creating for us to be able to mark it. We need both pieces of document for a single part and Excel spreadsheet. And in the event that you're doing assemblies, I need the assembly, the product file, all the parts, and the design table that goes with that particular product. All right, the only issue here may be the fact that when people did this problem for homework, many of them did not respect the fact that the center of that circle must be at the continuation of these two lines, and the center of this circle must be on that edge. This is the only one, the major problem that you have if you are not careful about it. Okay, so let's go ahead and make this. It is, I'm doing it as a solid part, but you're responsible for being able to do it as a surface. Okay, so on that vertical plane, I will sketch, and there are many ways of doing it. This is how I'm going to do that. You do whatever you want. So let me first make a piece like that. This is going to be basically that end. Okay, another line going like so. We have to do some cleanup here. First of all, hoping, yeah, good. Now, for this end, let me actually move this thing a little bit on that side. So I'm going to make an arc. So the arc, the center of the arc must be right above that, and the arc must be tangent to it. Tangent. And I'll go like this. We'll clean it up. And the other thing is that this arc must be attached to that. In other words, you should not be able to separate. Let me see if I can separate it. No, good. It's attached right now. Otherwise, you have to make sure that there is a coincidence between the two ends. Now, here I'm going to draw a line from that point to that center, okay, and do a little bit of a cleanup here. Quick trim, get rid of this and get rid of that, okay? And so this center must be on that line. If not, we have to fix it. We'll find out. In other words, can I just go ahead and, can I just go ahead and move that point? Yeah, see, it's not. It's not. So what I have to do is this line control that point. I'm going to make them coincident. All right, let's do the other end. The other end, I'm going to draw an arc here and then do a cleanup. Get rid of this, get rid of that, and that, and that. And once again, this point must be on those two lines. If it's not, we have to fix it. Let's find out. You see, it is not. And that's what may cause a problem for some of you when you do parameterization. That was an issue. So this line control that point must be coincident. Okay. And by the same token, this line control that point must also be coincident. You may have got a full mark when you showed your work to the GA, but you should have known that you should know that those must have been respected. Now, when I move this, notice that the center of that circle stays on both lines. Very good. Let's dimension these things. So I want this thing to be later on R1, this thing to be later on A, this to be R2, this dimension later on to be your beta probably, and this to be your alpha. Very good. I think we have taken care of everything. Exit. and then we pad it. Because we're going to be applying material, we will have to do a dummy material on this. So let's apply a dummy material right there on that part. It doesn't matter what it is, copper, and then we say okay. The dummy material has been placed on there. And please, the next step is to go and rename these things. Remember, the way I'm doing it this semester in this course offering is renaming. Okay, I'm not introducing parameter if you go to the some of the years prior to this semester. Okay, so we go to f of x. Okay, we go to f of x. We click on the part. All the stuff that we want, all the dimensions are going to appear here. I want this thing to be my w. Change this thing w. This thing to be my r2. Apply. This to be beta. Apply. Let's see what else we have. We want this to be alpha. Alpha. Apply. This to be A. Apply. And this thing to be R1. R1. Now, we also want our material, if you go scroll down, because we applied the material, there's the default name, but I want this thing to be not a material, be MAT in my spreadsheet. Apply. Also the part number, I want it to be serial number. Okay? So we go serial number. But what happens is that when I say apply, it puts the part 1 in front of it. So there's not much we can do here if we go this route. And then you can check your rename parameters. They're all here. You can see that. And then we say, okay. So we renamed everything. Now we go and create our design table. You go down here to this toolbar, which has f of x in it, right here. The fourth icon from the left. And we want to create a design table with current parameter values, not with the first one, not with a pre-existing file, but this one which says create a design table with the current parameter value. And then you say, okay, this is where you want to put, well, first of all, what do you want to put in that table? The easiest way is to say, show me the rename parameter I'll tell you. First column, serial number. Second column, material. Third column, let's see what we have in the third column here. R1 or 2. Okay, so R1 or 2. So R1, and then R2, and then A, and then W, and then alpha, and beta. And then as soon as we say, okay, it says where do you want to put it? So I'm going to put it in that, say, in my assignment number 4. Oh, sorry, assignment number 7. Assignment number 7. All right. And assuming we didn't make any mistakes here, this part of the design table appears right there. Copper, remember the dummy material that I put, and these are the parameters that I've used. So if you want to say edit table, the first row, actually, I don't want it. Let me get rid of the first row completely, because these were the default, or the, what do you call them, the nominal values. So I'm going to delete this and put my own stuff in there. And the table, basically, what I have to do is to put this table in there. So I'm going to do that without going back and forth. I have the table in front of me on a piece of paper, so I'm going to do that. Where is this? There. So we go AAA, BBB, CCC, steel, uppercase S, TEEL, lowercase, brass, uppercase B, RASS, uppercase G, OLD, lowercase OLD. And these values are 20, second row is 25, next row is 30, For R2, I have 49, 40, 50. For A, 47, 36, 40. For W, we have 20, 10, and 5. Alpha, you have 30, 40, 35, and for this is 20, 30, and 35. Please note that you can do a cut and paste from any other document to put it in the Excel spreadsheet. Now, if you put ridiculous numbers here, the sketches may be self-intersecting. If you were not careful about those constraints, the point being on those lines, you will run into that situation, even with these numbers, okay? So the next thing is you save it, and make sure you close it. You have to save, and you have to close, so that the synchronization takes place. And there we are. Now, this is the first row. Notice that the material is steel, name is AAA. If I say apply, it should resize according to those dimensions. There. Next row, BBB, brass. If you say apply, it should resize assuming there are no issue with the sketches and the part. There we are. And last row, CCC, gold, apply, and there we are. If you put ridiculous numbers so that the sketches here based on these numbers becomes self-intersecting and things disappear, then that's a different story. You say, okay, please remember when you save this thing, if this was a test problem, you would have to give us this part file and the Excel spreadsheet. That's pretty much it, folks.